Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiq bin Adam. Today I want to present about my project, which is development of environmentally friendly cup lid. Okay, this is our background study which relate to my project. In this study, we highlight aspect of material which use kena fiber, ABS and ABS. Manufacturing process use FDM and design process by apply design concept and study from design in Google pattern. Okay, for problem statement explanation, for the first problem statement is current cup lid use thermoforming machine, and based on survey that made by 2005 European benchmarking survey of energy consumption state that thermoforming required 6.179 kilowatt per kilo per hour compared to extrusion which is 1.346 kilowatt per kilo per hour. And for the second problem statement explanation is polypropylene can be recycled, but it is difficult and costly compared to produce new polypropylene material. And for the lastly, for product surface that use FDM, it have rough surface because of layer. And for thinnest part, it cannot fully printed and some area cannot be covered. Okay, for objective, we have three objectives in this project. First is to design our product according to PDS. Second is to fabricate our product by using FDM. And lastly, to study our product design performance. Okay, for scope of work, we focus to make this product following the product design development method. Next, we study from journal, and we have study in term of FDM, natural fiber and design. And lastly, we try to implement a new development for this cup lid. This is an example of journal that we study for our literature review. Okay, for methodology, we have used several methods to produce our product. It is start by using design. Okay, for design, we start with product design specification. In this PDS, it has several criteria that we need to highlight in order to produce a cup lid. For concept design, we come up with three concept design for cup lid. Okay, for the concept selection, we use Park metric. Okay, in this selection, we has highlight the several criteria that we need to analyze, and we use a baseline which is current cup lid that already in market. Then we compare with our three concept. Okay, for the scoring, we have -1, which is indicate the not good compared to baseline, and the +1, which is it is good compared to baseline. And for the score, we add the score, and the highest total score will be selected as our final design. This is our product overview, contain the sketch for final design, CAD model together with drawing, and the final product that already been print out by FDM. Okay, for the next method is FDM. In FDM, we use FlashForge Creator Pro to print out our product. And at the slide, we can see the specification for this machine. And we also use the Flash Print as our slicer software. In this software, we can set the product in terms of its size, its orientation, and we can choose the extruder we want to use, the temperature, and the resolution and other parameter that we can find in this software. We can set it based on our need. Okay, next for the filament use, we use 7.5% of kena fiber and ABS. And for the printing parameter, this is the parameter that we use to print our product. Most of the parameter is based on the recommend by FlashForge, but we make some change to temperature because FlashForge recommend to use 220 Celsius for extruder, and it is for ABS. But when we try to follow the temperature, we can see the kena fiber ABS is not suitable to go with that temperature. So we reduce the temperature to 215. It is same with the bed temperature. When Flash Forge recommend to use 105, then we decrease the temperature to 100 at 100 Celsius, because we can see the filament of kernel fiber is not suitable to go with the ABS parameter. Okay, for the next methodology is testing. First we do is a surface roughness test by using IPX 103104. This equipment is not big, it is small size and portable, and it is also did not require too much step to set up, and it only need calibration step at the first. After the calibration, we can start to take a measurement. We just put the probe on the surface, then the reading will appear in terms of RA and RZ. Okay, second testing is finite element analysis FEA that can be done in SolidWorks simulation. Okay, in this simulation, firstly we set up the material that we use, which is kernel fiber ABS and ABS. Then we fix the geometry at the bottom of the product. Then we apply the force on at the top of the product, which by use 300 Newton, which is equal to 30 kilogram. Then after that we run the simulation and we get the result for stress, strain and displacement for these two materials. Then for the next testing is eco web design evaluation. In this evaluation we have list down the several criteria that relate to sustainability, and they have in this evaluation it have a score, which is 4 very good, 3 good, 2 okay, 1 bad and 0 very bad. For the scoring, we put the score based on the material performance towards the criteria. Then we add the score, and we can see the total score, which is the high total score indicate the material is more sustainability compared to the others. For the last testing is we do on failure analysis. In this analysis, we need to identify the root cause that will be the contributor to our printing failure, and we find that inconsistent filament size and the unsuitable parameter used become the contributor to the printing failure. Okay, for the result and discussion, we start with the surface roughness testing. Okay, this are the data that we get after performing the testing. We have 5 different points at the top of the surface for the product, and after that we calculate the average, and this reading in terms of RA value. RA is a measurement of average length between peak and valley from mean line on entire surface of sample. Okay, in surface roughness, the lower RA value indicate the surface is smooth. So the higher the RA value, the rougher the surface, and this we can conclude that kernel fiber ABS has a smooth surface compared to ABS. Okay, for the next result is for finite element analysis. Okay, this are the example of the result that we get after we perform the simulation between these two of the material. We can see the yield strength for these two material is not too much different, and for the maximum stress also we can see that ABS has the higher maximum stress value compared to kernel fiber. Okay, for the displacement value, kernel fiber has a lower displacement value compared to ABS, and we can see that as low displacement value is good compared to high displacement value. But this material start to deform after we apply the 300 Newton of force, and 300 Newton of force is about 30 kilogram, and we consider that these two material is considered as a strong material because it can support about 200 plus of Newton with the equal to the load 20 kilogram. Okay, next, the result for eco web design evaluation. In this evaluation, we list down the several criteria that we need to analyze in terms of sustainability. Then we put the score for each of the criteria. After that, we total up the scoring and see which material has the higher total score. From this, we can see that kena fiber ABS has a 25 score compared to ABS, which is as 23 score. This is shown that kena fiber ABS is more sustainability compared to ABS. Okay, this is the result for final analysis in terms of inconsistent filament size. We take a measurement from the 5 filament at the start of the filament, at the middle of the filament, and the end of the filament by using digital vernier caliper. This is we can see the measurement is not according to the standard, because we can see it is some of the filament as the bigger than the standard, and some of the filament has the smaller than the standard. The inconsistent filament size will affect to machine performance, which filament cannot flow out from the extruder and it will be stuck inside the nozzle and tube. Okay, the next result is for parameter in terms of temperature. For the platform, we try to use 100 F5. This is the temperature that recommended by Flash Force, and we observe that the brim of product is slightly rise slightly. Then we decide to decrease the temperature to 95 Celsius. Then we can see that our brim of product not stick on the platform. So we take a decision to use 100 Celsius as our bed temperature, and we can see that the product can print out. For the nozzle temperature, we decide to use 215 because we already print the temperature tower. At the temperature tower, we can it has a different temperature with different surface texture, and we can see that 215 is have good texture compared to the others, so we use 215 Celsius as our extruder temperature. Okay, for the conclusion, firstly I want to conclude from the testing that we have done. Okay, for the surface roughness, we can conclude that kena fiber ABS has a good surface finish compared to ABS. Then for the FEA analysis, we can see that ABS is more strong compared to kena fiber ABS, but kena fiber ABS also can be considered as strong because it also can withstand the force, which is 200 Newton of force, and start to deform after we apply 300 Newton of force. This different because of their yield strength, slightly different of yield strength. Okay, then for the Eco Web design evaluation, we can see that kena fiber ABS is more sustainable compared to ABS, based from the total score that we get. And lastly, for the failure analysis, we consider that two major cause for our failure during printing is inconsistent filament size and unsuitable parameter. So if we can overcome these two aspects, then we can print our product successfully. Then for the overall conclusion, we can conclude that KNAF ABS is good in terms of surface finish and sustainability, but in terms of strong, it also can be it also strong, but ABS is more stronger than the kena fiber ABS. And for the failure aspect, we need to overcome this problem so we can do our printing successfully. Okay, this is an example for our product, which is kena fiber ABS cup lid. We use together with the paper cup. Okay, we can see Okay, but development or improvement need to be done to this cup lid because it is still in the early phase, so it cannot grip too tight with the cup lid. And okay, for this in this project, we also uh, want to observe the performance of the material when we try to print out the thinnest material. We can see cup lid is one of the example of the thinnest product. Okay, this the we can see the diameter, the thickness is about 0.4. Because we use the extruder 0.4, then it managed to print out the 0.4 for the thickness. And this the ABS that we also print with the same parameter for the dimension, same size but use different of parameter in terms of temperature. And we can see the difference for the surface roughness. Okay, these are the example for our final product, kena fiber ABS and fully ABS. Thank you.